In this lesson, we're going to be looking at applications of exponential functions, either using an exponential growth model or an exponential decay model. The forms for exponential growth and decay are almost identical. The only difference is that for exponential growth, the growth rate is positive, and for exponential decay, the growth rate is negative. Regardless of whether we're dealing with exponential growth or decay, in both forms for those functions, this coefficient 2e represents the initial amount. And the initial amount is going to be the amount when time is equal to 0. Starting with example 1a, we are initially told that 20 pythons were recorded as captured or killed in 1995, and then they go on to tell us that by 2009, the number had increased to 378. And our job is to write a function that represents the number of pythons captured or killed t years after 1995. This saying right here is crucial because it tells us that 1995 is our starting year. That's our initial year. So if we know that 1995 is the initial value, then we can see that we had 20 pythons initially when t is equal to 0 in 1995. That gives us our y0, our initial value. So far we know that the formula or the function for this will be p sub t is equal to 20 e to the rt. We still don't know what r is, and to find out r, we're going to have to use the fact that by 2009 the number had increased to 378. Now from 2009 back to 1995 means that 14 years had passed. So when t is equal to 14, we're getting out 378. So this sentence here underlined in green tells us that p of 14 equals 378. I'm now going to apply that to this equation here that says when I plug in 14, we get out 378, which is exactly what we have done here. And now we can use this equation to solve for r, because in the previous lesson we learned how to solve exponential equations. So I'm dividing both sides by 20 to get the exponential by itself. And now that I have the exponential by itself, I'm going to come in and take natural log on both sides of this equation. And I'm doing that because I know that natural log and e will cancel each other out and simply leave me with 14 times r on the right side of the equation. And then to finish solving for r, we will need to come in and divide both sides by 14 to give us that r is approximately 0.2099. So our final answer for the function is p of t is equal to 20, that's the initial amount, e to the 0.2099. Part B asks us to go on to approximate the number of pythons captured or killed in 2017. In 2017 would mean that t is equal to 22. We know that 1995 was year 0, so one way that we could calculate that is we could take 2017 and we could subtract from it 1995, which would give us 22 years have gone by. So we're just plugging 22 into the function. So we have 20 multiplied by e raised to the 0.2099 times 22, which gives us approximately 2,025 snakes that have been captured or killed in 2017. Notice I rounded that to a whole number because we are talking about snakes. In part C, they're asking us to find the year where 250 pythons were killed. So we want to solve for t. So we're going to set the entire function equal to 250, and we're going to solve this equation for t. We start off by isolating the exponential, so we're going to need to divide both sides of this equation by 20. Once we have this exponential by itself, we can then come in and take natural log on both sides of this equation. Taking natural log on the right side of the equation is going to cancel out the e and simply leave us with whatever was in the exponent. Then, to finish solving for t, we'll come in and divide both sides of this equation by the coefficient of t. This leaves us with t is approximately 12. And if t is approximately 12, we need to take the year 1995 and then add 12 years to it to end up with the year 2007. In example 2, we are told that we have a sample collected from a cave painting. Only 2% of the original sample is still remaining. We're asked to determine how old is the sample, so we want to find time. We are not told what the initial amount of the carbon-14 sample is. Let's say that we had 100 grams of carbon-14 initially. We are being asked to figure out how much time went by to dwindle us down to only 2% of that 100 grams. Well, 2% of that 100 grams would then be 2 grams of carbon-14 remaining. So we are looking for how much time passed where 100 grams would decay down to 2 grams. So I've set up this equation with where t is unknown. I do not know what t is. And we're going to come in and solve for t. So I'm going to divide both sides of this equation by 100, leaving me with 1 over 50 is equal to e to the negative 0. Be careful with how many zeros you're putting before or after your decimal place, rather. Now that we have the exponential isolated, we can come in and take natural log of both sides of the equation. When we take natural log on the right side of the equation, it's going to cancel out with the e and only leave us with what is in the exponent. So I'm going to go ahead and just write the exponent that's left. And then to finish solving for t, I would need to come in and divide both sides of this equation by that coefficient to give me that t is approximately 32,331 years.